الرحمن الرحيم. السلام عليكم ورحمة الله وبركاته. Section 3.2 Power and some rules. The aim of this section to develop rules that will help in computing derivative in a faster way than the definition, which is 3.1.1. So the first theorem in this section is Theorem 3.2.1 Power Rule. For any real number n, the derivative of x power n will be equal to n multiplied by x power n minus 1. So the derivative of x power n will be given by n multiplied by x, and then we will subtract 1 from the power, it will be n minus 1. يعني إذا كانت عندنا x باور n اللي هي باور ونريد نجيب المشتقة بتكون n مضروبة في x باور n minus 1. نضرب الأس في الدالة وننقص واحد من الباور. So let us see the example. Differentiate a, we have y is equal x power 7, b y is equal x, c y is equal x power minus 2 over 3, d y is equal root 2. So according to this theorem, the derivative of x power n will be n multiplied by x power n minus 1. So the first one we have y is equal x power 7. So our n here it is equal to 7. The derivative will be equal 7 multiplied by x power 7 minus 1, which is 6. So with n is equal 7, dy over dx is equal 7x power 7 minus 1. And we know that 7 minus 1 it will be 6. So the derivative of x power 7 will be 7x power 6. by is equal x. So here the power is 1. So with n is equal 1, dy over dx it will be 1 multiplied by x power. We'll subtract 1 from the power, it will be 1 minus 1. So 1 multiplied by x power 0, it will be x power 0. And we know that x power 0 it is given by 1. See, we have y is equal x power minus 2 over 3. So the power here it is minus 2 over 3. It will be minus 2 over 3. So the derivative minus 2 over 3 multiplied by x power. Minus 2 over 3 minus 1. We subtract 1 from the power. So it will be minus 2 over 3 x power. Minus 2 over 3 minus 1. It will be minus 5 over 3. So we conclude that the derivative of x power minus 2 over 3 is given by minus 2 over 3 x power 5 over 3. Then we have d, y is equal x power root 2. So here n is equal root 2. The derivative will be root 2 multiplied by x power root 2 minus 1. So we apply this theorem, which is the power rule theorem, applied for any function to find the derivative. Then we have the second theorem, which is constant function rule, theorem 3.2.2. If fx is equal c is a constant function, then f prime x is equal 0. So if the function is a constant, then the derivative will be equal 0. Let us see the proof for this function. So here we say let us our function let f of x is equal to c. We want to show that f prime x is equal 0. So we want to show that the derivative is equal 0. So we use the definition. So f prime x is equal limit of fx plus h minus f of x over h, and we take the limit when h approach to 0. So here our function f of x is equal to c, so let us apply it here in this definition. So f x plus h, we go to the function fx, replacing any x by x plus h. Since here we don't have any x, so fx plus h will be c minus f of x, which is the original function, c divided by h. We take the limit when h approach to 0. So this will give us limit h approach to 0. C minus c will be 0 divided by h. So this will give us limit of 0 divided by any number or by any variable. It will be 0. When h approach to 0, this will give us 0. So from here we prove that the limit of any constant number will be equal 0. Then we have theorem 3.2.3, which is constant multiple rule. If C is any constant and f is differentiable at x, then Cf is differentiable at x, and it is given by the derivative of Cf of x is equal C multiplied by f prime x. So if you have a constant C and it is multiplied by a function f, you want to find the derivative of the constant multiplied by the function, you can take that constant out and find just the derivative of the function. So the derivative of C multiplied by f, it will be equal C multiplied by f prime. Let us prove this theorem. We want to prove theorem 3.2.3, derivative of C multiplied by fx is equal C multiplied by f prime x, where C is any constant. So let us prove this theorem. First, we define a function, for example, g of x, which is equal C f of x. Now we want to show that we want to show that the derivative g prime x is equal C multiplied by f prime x. So we will use the definition to find the derivative of g prime x, and we know that g prime x is equal limit of g x plus h minus g of x divided by h, and we evaluate the limit when h approaches to 0. So this will give us, it is equal to limit gx plus h. We know that our g is equal c multiplied by f of x. So this will be equal c multiplied by f. We're replacing any x by x plus h minus g of x is the original function, which is c multiplied by f of x, and we divide the function by h, evaluating the limit when h approaches to 0. So here we have limit of c multiplied by fx plus h minus c multiplied by f of x divided by h. Since here we have c and here we have c, we can take it as a common factor. So this will give us limit of c multiplied by f of x plus h minus f of x divided by h, and we evaluate the limit when h approaches to 0. And we say that if we have a constant multiplied by a function, we have the limit, we can take the constant out. So this will be equal c multiplied by limit of fx plus h minus f of x over h when h approaches to 0. If you see this one, this one is just the definition of f prime x. So we conclude here this one, it is equal to c multiplied by f prime x, and we prove that the derivative of g prime x will be c multiplied by f prime x. Example 2, a constant multiple, differentiate y is equal 5x power 4. So here we have our function is 5 multiplied by x power 4. It is a constant multiplied by a function. So the derivative will be equal the constant multiplied by f prime. So dy over dx, it will be equal 5 multiplied by the derivative of x power 4. So 5 multiplied by d over dx of x power 4, which is equal 5. Derivative of x power 4, here we will use the power rule, it will be 4x power 4 minus 1, which is 3. So now we have 5 multiplied by 4x cube. 5 multiplied by 4 will be 20, and here we have x cube. So the derivative of 5x power 4 will be 20x power 3. Then we have theorem 3.2.4, sum and difference rules. If f and g are functions differentiable at x, then f plus g and f minus g are differentiable at x, and the derivative of fx plus gx will be f prime x plus g prime x. Similarly, the derivative of fx minus gx will be f prime x minus g of x. The derivative of g prime x, sorry. So if f and g, both of them are differentiable, you want to find the derivative of the sum, or the derivative of the or the derivative of the subtraction between these two functions, just you need to distribute the derivative operator. So it will be the derivative of f plus derivative of g. Similarly, derivative of f minus g will be derivative of f minus derivative of g. So the derivative of a sum is the sum of the derivative. Here we have example number 3, polynomial with 6 terms. Differentiate y is equal 4x power 5 minus half x power 4 plus 9x cubed plus 10x squared minus 13x plus 6. So here we have 6 terms. In between we have subtraction and addition. So to find the derivative of this function y, just we need to distribute the derivative operator, the operator of the derivative. So here we have dy over dx will be equal 4x power 5. 4 is a constant, so just we need to find the derivative of x power 5 with respect to x minus 1 over 2 multiplied by x power 4, so 1 over 2 is a constant. We need to find derivative of x power 4 plus. Here we have 9x cubed, so 9 will be constant multiplied by the derivative of x cubed plus 10 is a constant. We need to multiply by the derivative of x squared minus 13 is a constant. We need to multiply by the derivative of x plus derivative of 6. So we know that derivative of a constant number is equal 0. So let us find the final result one by one. So 4 will be the same. Derivative of x power 5 will be 5x power 4 minus half will be constant. Derivative of x power 4 will be 4x power 3 plus 9 is a constant. Derivative of x cubed will be 3x squared plus 10 is a constant. Derivative of x squared will be 2x minus 13 is a constant. Derivative of x will be 1 plus derivative of 6, which is derivative of any constant, will be equal 0. So now just we need to collect all the terms. So 4 multiplied by 5 will be 20x power 4 minus half multiplied by 4 will be 2x. Here we have cube plus 9 multiplied by 3x squared will be 27x squared plus 10 multiplied by 2x will be 20x minus 13 multiplied by 1 will be 13. And here we have 0. Find the points on the graph of fx is equal minus x cubed plus 3x squared plus 2 where the tangent line is horizontal. We know that if the function has a horizontal tangent line, that means the slope of this tangent line is equal to 0. So first we will find the derivative, then find where this tangent line is horizontal. So we'll make f prime x is equal 0. يعني إذا السؤال قال إنه find where the points where the tangent line is horizontal, that's mean إنه derivative is equal to 0. إذا نجيب الدerivative نساوي الدerivative بالزيرو نجيب البوينتس لما الدerivative is equal 0. So first of all, fx is equal minus x cubed plus 3x squared plus 2. The derivative of this one will be f prime x is equal. Derivative of minus x cubed will be minus 3x squared plus derivative of 3x squared will be 2 multiplied by 3, so it will be 6x plus derivative of 2 will be 0. So f prime x is equal minus 3x squared plus 6x. We find the derivative, then we need to find where this derivative is equal to 0. Why we make it equal to 0? Because we have here a horizontal tangent line. And for any horizontal tangent line, the slope is equal 0. So f prime x is equal 0, that's mean minus 3x squared plus 6x is equal 0. Now if we take minus 3 as a common factor, so it will be minus 3 multiplied by x squared minus 2x is equal 0. So either minus 3 is equal to 0, which is not acceptable, or x squared minus 2x is equal 0. So from x squared minus 2x, we can take x as a common factor. So it will be x multiplied by x minus 2 is equal 0. Either x is equal 0 or x minus 2 is equal 0. So here we have x is equal to 0 or x is equal 2. So we have 2 points where the tangent line is horizontal. Now we want to find the y coordinates. To find the y coordinate, just to go to this function, replace any x by 0 to get 0. F of 0 is equal 0 and 2. Because here we replace x by 0, replace x by 0, we'll get 2. So the first point is 0, 2. And for finding the second point, just go to this function, replace any x by 2, so minus 2 cubed plus 3 multiplied by 2 squared plus 2. This will give us 6. So we have 2 points where our tangent line is horizontal. The first one is at 0, 2, and the second one at 2,